Important trends and anomalous properties of boron. Here, the group 13 element, see some the trichlorides, tribromides, and triiodides of all these elements being the covalent in nature and hydrolyzed in water. So, the species like M metal OH 4 times, that is minor. Here, this is the species like tetrahedral, and the species like octahedral is H2O 6 times 3 plus. So, this species like tetrahedral and the octahedral, except in the boron, exists in aqueous medium. So, the monomeric trihalides being electron deficient are strong Lewis acid. So, boron trifluoride easily react with Lewis base such as ammonia to complete the octet around boron. For example, so this is the trifluoride boron trifluoride, and react with ammonia. So, ammonia having a lone pair of electron. Now, complete the octet, giving off that E electron, that unshared electron pair. So, because due to the absence of d orbitals, that the maximum covalence of boron is 4. The covalence is 4. Since the d orbitals are available with aluminum and other elements, that maximum covalence can be expected beyond 4. So, most of the other metal halides like aluminum chloride AlCl3 are dimerized through halogen, bringing like this Al2Cl6, that is the dimerase form. So, the metal species completed acted by accepting electron from halogen, this halogen bridged molecules. Okay. Next is some important compounds of boron. Some important compounds on boron is first borax. The borax is the most important compound of boron. It is a white crystalline solid. The formula is Na2B4O7 dot 10H2O. This is called borax. So, in fact, it contains the tetranuclear units. So, the tetranuclear units like the B4O7 OH 4 times 2 minus. So, and the correct formula is for this the boron borax is Na. You have to write like this: Na2 B4 O5 then OH 4 times dot H2 8H2O. So, this is the borax dissolved in water to give an alkaline solution. So, we can write that equation, that is Na2 B4O7 borax react with water, that is dissolved in water, to give orthoboric acid and sodium hydroxide. 4 moles of BO3. This is orthoboric acid. Again, this on heating, the borax first loses the water molecule and swells up, and further heating it turns into the transparent liquid, so which solidifies into glass like material, is called borax bed. So, Na2B4O7 dot 10H2O. So, borax on heating gives sodium metaborate, Na2B4O7. This is sodium metaborate. Again further on heating you will get boric anhydride. That is boric anhydride to NaBO2 plus B2O3. This is boric anhydride. So anhydride means without water molecule. So the metaborate of many transition metals have characteristic color, and therefore the borax bed test can be used to identify them in the laboratories. Okay. For example, the borax is heated in the Bunsen burner flame with cobalt oxides on loop of platinum wire. A blue colored bed is formed. Okay. Next is a orthoboric acid. Orthoboric acid, the H3BO3, is a white crystalline solid with soapy touch. So it is sparingly soluble in water but highly soluble in hot water. So it can be prepared by acidifying an aqueous solution of borax, that is Na2B4O7, react with that acidify, that is dilute acid. You will get orthoboric acid, sodium chloride and orthoboric acid. The orthoboric acid formula is B, 4 moles of B, OH thrice. That is H3BO3. Then it is also formed the hydrolysis of most boron boron compounds. So it has a layer structure with planar BO3 units, that is BO, boron oxygen units are joined by the hydrogen bond. So usually that structure will be so like this, the structure. See, the dotted line indicates that hydrogen bond formation. Hydrogen. So like this. This is the structure of that is the partial structure of boric acid. The dotted lines. This dotted line represents this hydrogen bond. Then the boric acid is a weak monobasic acid. It is not a protonic acid but act as a Lewis acid by accepting electron from the hydroxyl group. For the example reaction is orthoboric acid react with water. We can write it like this: HOH, this is water, then form a complex and the hydronium ion. So on heating, the orthoboric acid above 370 Kelvin forms metaboric acid. So the HbO2 which on further heating the yields boric oxide, that is called B2O3. So that is H3BO3. The reaction is H3BO3 on heating. You will get HbO2. Further on heating, you will get this B2O3, that is boric oxide. And next is a diborane. B2H6, that is called diborane. The simplest boron hydroxide is called diborane. It is prepared by treating of boron trifluoride with lithium aluminum hydride to form boron in the diethyl ether to form diborane. Then it is a convenient laboratory method for the preparation of diborane involves the oxidation of the sodium borohydride with iodine. So this is the reaction, sodium borohydride with iodine to form a diborane. Then the diborane is produced on the industrial scale by the reaction of boron trifluoride with sodium hydroxide, sorry, sodium hydride. The sodium hydride on heating 450 Kelvin, you will get diborane. Then it is a diborane is a colorless, highly toxic gas. So the boiling point is 180 Kelvin. The diborane catches fire spontaneously upon exposure to air. So it burns in oxygen, releasing an enormous amount of energy. Okay. So here the diborane is reacted with the oxygen to form the P2O3, then water molecule. So here the combustion enthalpy of combustion reaction is minus 1976 kilojoule per mole. Okay. So this is a toxic gas, and most of the higher boranes are also spontaneously flammable in air. So boranes are readily hydrolyzed by water to give boric acid. Let's see here, this is a boric acid. Then the diborane undergoes some cleavage reaction with Lewis base to give borane adducts with BH3 Lewis base. See here the reaction with like methyl group, any methyl group to form like this. Okay. Then that B2H6, suppose if you add the carbonyl group, means that is B2H6 react with the 2 moles of the carbonyl group to obtain 2BH3 dot CO. Okay. Here the attaching group is the Lewis base. Then the reaction of ammonia with diborane, this diborane gives, that is initially you will get like this. Then it is formulated, that is you will get a complex like this. Then further on heating it gives borosine, that is also called inorganic benzene. This is name is called borosine and is also called inorganic benzene. Why this is called inorganic benzene means, look like the structure like a benzene, so that this is inorganic benzene. The BH and NH group in alternate position. Okay, look at this, BH, NH, BH, NH. So the alternate position. Okay, the you can see the structure of diborane in your textbook. That is, they have 4 terminal hydrogen atom and 2 boron atoms lie on the one plane, and below this plane, that is, there are 2 bridging hydrogen atoms are there. Then the 4 terminal BH bonds are regular 2-centered 2 electron bonds, while the 2 bridge like BHB and BH bond. Okay. Boron, uses of boron and aluminum and their compounds. So the boron being extremely hard refractory solid of high melting point, low density and very low electrical conductivity. So finds many applications, like the boron fibers are used in making a bulletproof vest and light composite material for aircraft like this. Okay. Then the main industrial application of borax is boric acid is the manufactures of heat resistant glass, glass wools and fiberglass like this. And the borax also used for flux for solving material for heat, scratch and stain resistant glassed coating of earthenware and the constituent of the medicinal soap. Okay, then the aluminum is a bright silvery white metal with high tensile strength. So it is high electrical and thermal conductivity on weight to weight basis. Okay. So the electrical conductivity of aluminum is twice that of the copper. So aluminum is used as extensively in industries in everyday life. For example, forms alloys with copper, manganese, magnesium, silicon, like this, and zinc. So aluminum alloys can be given a shape of pipes, tubes, rods, wires, plates or foil. So and therefore find uses packing, utensils, making construction, aircraft surface like aeroplane transportations of industries like this. So aluminum having many uses in the domestic purpose also. Next class we will discuss the group 14 elements.